This video will cover the second page of notes for the topic of rational equations. Let's start with example number 2, where our job is to solve the rational equation of x over x minus 2 plus 1 over x plus 2 is equal to 8 over x squared minus 4. Let's go down our steps. Our first step would be to find our domain restrictions. That means we look at every fraction and we set each of those denominators equal to 0 so that we know that x cannot equal to 2, otherwise this fraction will be undefined. X cannot equal to negative 2 because this fraction would be undefined. So you can see those two have been stated here. When we look at this third fraction, notice it's quadratic, so I'm going to factor this to x plus 2 times x minus 2 and set it equal to 0. We're going to notice that we actually have the exact same values that will make this particular fraction undefined as well. So we have found all the domain restrictions. For step number 2, our job is to find the LCD, because what we want to do is to be able to multiply every single one of these terms, these three terms, by the LCD such a manner that we'll get rid of every single denominator. Well, we know that if we multiply this fraction by x minus 2, it will get rid of the x minus 2 in the denominator. But remember, I have to multiply this one by the same thing, and I have to multiply this one by the same thing. For the second fraction, we notice I would have to multiply it times x plus 2, and that will get rid of the denominator x plus 2. So that means this one has to be multiplied by x plus 2, and this one has to be multiplied by x plus 2. Notice when we factor this, we had exactly x minus 2 and x plus 2. So when we already multiply these at the top with these at the bottom, they will cancel out. So I think we found our LCD to be x minus 2 times x plus 2. So essentially, you'll know if you have the correct LCD, when you multiply, there should be no more fractions. So if this is our LCD, and we multiply it times our first fraction, here's our LCD, and we're multiplying it times our first fraction, we can see the x minus 2's will cancel. Here's my LCD, and I'm multiplying it times the second fraction, we'll see this x plus 2 will cancel. And then this is our LCD. We multiply that times the top. That's how we get the LCD times 8. And then we still have the bottom, and we'll notice that all of these will cancel out. That will leave me with just x plus 2 times x. That's where this one came from. The second term gave me x minus 2 times 1. And then over here, everything canceled but the 8, and that's where this 8 came from. We were successful in finding the LCD because notice the equation we have left here does not have any fractions, does not have a denominator. So we'll go to step number 3, which is to solve for x. So I'm going to get rid of parentheses. That's how you see the distributive property here to get x squared plus 2x. I can get rid of the parentheses here as x minus 2 is equal to 8. I'm going to combine like terms, and this is now the equation I need to solve. Remember what I said. If you had something that looked like x squared is equal to 0, try factoring and see if you can go from there. So I got to set it equal to 0. So I'm going to subtract 8 to both sides, and now I have a quadratic equation that I can solve. Factoring, I get this statement right here. And then I'm going to set each one equal to 0. So x minus 2 is equal to 0. That will give me x is equal to 2. Over here I will have x plus 5 is equal to 0, which will give me x is equal to negative 5. For step number 4, our job is to check with the domain restriction. So if we come up here, we'll find our domain restriction says you can be anybody and everybody except 2 or negative 2. When we come back down here, we found x is equal to 2, but we just said it could not be negative 2 or positive 2. So this is a no-no because it's not in the domain. However, x is equal to negative 5 is okay because it is in our domain. So the last thing we need to do is to write our solution set. That concludes this video.